Hello coders, in this video we will see the next question in our binary DFS list and let's see what the question is. Let me take you to the screen. Now, this is the question. The what question says that it is the question title is longest zigzag path in a binary tree. The word zigzag says you that we need to go first somewhere, then need to change direction, it again need to change direction, that is changing the direction at every step, that means the zigzag, right? So let's see what the question says. You are given the root of a binary tree. A zigzag path for a binary tree is defined as follow. Okay, what does mean the zigzag path for a binary tree? It is a choose any node in binary tree and a direction, right or left. If the current direction is right, move to the right child of the current node, otherwise move to the left. Okay, then change the direction from right to the left or the left to the right. Repeat the second and third step until you can't move in the tree. Until you can't move. When you can't move, when you reach to the leaf node, right? So we need to do this until from root to the leaf node, but we don't need to traverse it linearly, not linearly, or you can say linearly. We want to traverse it zigzag. First we will go right, then we'll go left, then right, then left, likewise, or first we will go left to the right, left, right, likewise. Okay, the zigzag length is defined as the number of nodes minus 1. Fair enough, cause if we have two nodes, we have one path between that two nodes. So they are saying ki if we have a n nodes we have visited, then the path of the zigzag path that we found till that node, the length of that path will be n minus 1. I return the longest zigzag path contained in the tree. Okay, we need to return longest zigzag path. How we can do this? Let's think we are at root. How many options do I have? As we are solving DFS and we are doing it recursively, we will see it like at right now what I can do, and I can repeat that thing. If I go to the if I have a next node and I go to that next node, then I'll repeat that same things. Okay, so if I am at node, then what I can do? If I am at a node, what I can do? I can take the path length which I am starting from now, which will be 0, cause if I go to the second node, then I can see it's one path. One path, cause the path is basically a number of nodes minus 1. So it's if it's n, then it will be n minus 1. And if we go to the second node, then the path length will be 1. Likewise, if I am at node, the path length will be 0. Okay, then I said ki okay, right now my path length is 0 and I want to go to the next node. How many options do I have to go to next node? I have two options. That is, I can go either to left or right. Okay, and if I okay, let's say I go to the left. When I go to the left, what I have to do? I have to increase the path length, right? And as I go to the left, I have to maintain that direction also, because on that node I have to change my direction to the right. I have to take the right direction. On that node, either I have that one option to increase my path length, that as I came from left, I have to go to right. Okay. So we need to maintain one direction variable also from node itself, that direction variable. And on that node, when we go to the net, as one was the bounded direction. Like bounded direction is what I mean to say ki I came from left, so I am bounded to go right now because I came from left. If I want to increase my path length, or I can start from here itself and I can go to the right or to the left also, because I came from let's say okay, let's take I came from left. Then I have two options. I can go to the left, I can go to the right. But as we want a zigzag path, when I came from left and then to that node and I go to the right, in this case the right case will increase the path length. Path length will increase. But in case of the same direction, that is I came from left and I'm going again to the left, So in that case, what I have to do ki, I have to set my path is equal to 0 cause I didn't follow the rule. I came from left and again I'm going to the left. So my new path is started. That's what I'm declaring here. And if I came from left and I'm going to the right, then it means I'm increasing the path length. Okay. So that's it. So that's what you need to understand. Now let's write the recursive code. How you can write the recursive code for this. For node, I already explained you everything, and that thing we need to just implement here. That we need to take the path length. Path length will be 0. And what I need to take direction. Let's say I am taking a char. Direction is equals to direction. Okay. And first my direction will be left, then my right. Likewise, it will be like this. Okay. uh, Direction is equals to, I'm taking first left. Okay, I'll go to the left and I'm at root. Then I have two options as I said. So I can say ki take my left zigzag path zig or my right zigzag path, right? Or what I can say ki instead of that, as I'm going and again as I'm changing my path length at every node, that as I said, let me, I think I erase that. 1 minute. Let me go to the here. Uh, as I said, when I came from left, and again if I want to go left, then I do path length is equals to 0. So it's like I'm changing the path at every node, right? Either it will be 0, either we are increasing it. So as we are increasing path, when we reach to the last node, can't we just store it? Instead of returning, can we store it? That's what I just thought. So we can do that. So let's take a max zigzag path is equals to 0 and int current length, or we can say just length, zigzag length, we should say zigzag length is equals to 0. And I have direction, that I'm saying I have character direction is equals to, yeah, I'll go to the left and I will say ki solve these things, go to the left, root left, and as I'm going to the left and I said ki I'm at root, so my length will be 0. So my zigzag length, I'll pass this as it is, and I'll pass the max length. I'll pass that address, okay, max length address, and I will pass the directions. As I'm going to the left, I'll pass this direction, and when I came back, I'll have a max path stored, like maximum length of that zigzag path will be stored, and again I will go to the right. Let me do this. Okay, I'll go to this. I'll go to the right, and again the path length will be 0. So I'll do that also. I have to change both, like path zigzag length is equal to 0 I need to do, and also the direction variable also I need to do. I'm going to the right. Okay, now we need to write a solve function, and after solving everything we need to return the max length, maximum path, return maximum path. Okay, so write down the solve function. Okay, we are writing the solve function because it is the main function. We can say ki here we were calculating the max length, so we are writing the main function of this question, we can say. So let's go. We'll take root, I mean as it is, like which node we are taking. This is a node we took, and then we have direction, that is char direction, zigzag path int, and we have this, and we'll like its address as I said, because I want to store the number of the path length that I have till covered. So take it like what like the best condition, as I said ki when I can stop, like as it said ki repeat the second and third step until you can't move in the tree. When you can't move in the tree, when that node itself uh, when that node itself a null node, you can't go, you can't go somewhere. Or also the if it is a child node, right? I'm taking if it is a null node, cause when I'm at a one node and I'm going to the second node, I'm already taking the length is 0, and when I go to the second node, then I'm increasing it. So I can mention ki if my node is equals to null, then I'll store my max zigzag path. Let's take max zigzag path is equals to maximum of that max zigzag path, and zigzag length. Okay, and I need to return from here. I can say ki it is my void function, not a in function. Now I'll check ki what is my direction. If my direction is equals to L, as I came from the left side, if it is yes, then I have to go to the right side to increase the length. So I'll take this, I'll go to the right and I'll increase the length. Go to the right and my direction will be here R. Okay, and I'll go and I'll increase the path. Otherwise, what I will do, I'll start a new path from here. I'll go to the left and my zigzag length will be 0 because I'm starting a new path from here. Okay, the same thing we need to do for right. If it is equal to right and if I'm going to the left, then what I have to do? I have came from right and I'm going to the left, then I have to increase the length, and as I'm going to the left, so I'll say ki I came to the left. And the same thing, if I want to start a new path, then I have to write roots right, and if I'm going to the right direction, I'll do right, and I'm starting a new path, so it will be 0 and max. Okay, that's it, and let's run it. What did it say? Root right. Oh, okay. What I'll do ki I'll change this root and this. Let's run this. Oh, still mistake and nothing. It is accepted and just submit it. What it says, it's saying a wrong answer. Output is 4 and expected is 8. What mistake we did here? If it is here, we passing R. Oh shit, we are passing R, then we have to go to the left. Okay, it's just silly mistake, guys. As I explained you, and my algorithm is correct, so it have to be accepted, and it has to be accepted, and yeah. So yeah, let's see what's the time complexity for this. Time complexity for this is as we are calling a recursion function, and we are calling this recursive function as height, and that height will be covered by 4 times, because for this also, for this also, for this or this. So as we are calling it 4 times, we can say 4 into height, basically height, right? So we go of height. And what is the time space complexity? Space complexity for this is will be big of 1 only, because we are just sorry. Space complexity for this will be big of h, because we are as it is recursion and it is a stack, the height of the tree, that much functions call will be there, and that much functions call, as we are called that much function, that much space will be used in the internally in that stack. So space complexity will be big of h, and time complexity will be big of n only, because we are visiting each and every node, and n is the number of node here. Okay, so yeah, that's it for guys for this video. We'll see in next video. Till then, bye bye.